Hello students and my dear viewers. Today I'm here again with something new for you, something extremely new. I mean, you are not familiar with it, right? We are going to discuss something rather than glass. Previously I was teaching you glass and things that are made up of glass, but today I am here with you to discuss ceramics. What are ceramics? It is also in your course, and it is one of the very, you can say, interesting topics, and I think you will be enjoying the background also. It's a beautiful background. I've selected this background for you people so that you can I mean enjoy this lecture with something new, right? You can see a fish aquarium. This is a beautiful fish aquarium, and this is my fish aquarium right now. So this is your Professor Dr. Moina Akhtar Mughal from Dr. Amakazi Institute of Chemistry, University of St. Jamshoro. You know me very well. I'm a professor and I'm serving there as a professor since last 24 years. So this is my brief introduction, and I am your very friendly teacher. You know me very well that I am your friendly teacher, right? So that is something interesting. So now let's come back to our, the topic we are supposed to discuss today. It's about ceramics. Now, you can simply see in our daily lives, we are surrounded by a lot of things that are made up of ceramics, right? We are using, smooth, beautiful, designed coffee cups, plates, and bowls, and a lot of, things that are used for our, daily usage. They are for our duty. Now, these should be handled very carefully, right? They are and with proper, of course, maintenance. Even in the laboratories, you will come across the pestle and mortar with which you can grind your compound. You would grind different compounds with the help of a pestle and mortar. So that is also a ceramic, product, right? It is made up of ceramic, right? So in the laboratories, we are also using ceramics, and they are, made by using a special, they are manufactured by using a special kind of a material. All these kind of utensils and lab, you can say, things that are used in lab are made up of these ceramics, right? Ceramics now includes manufacture of earthenware, number one, number two, porcelain, right? And bricks, of course, and sewer pipes, and electrical insulators, and earthenware, as I just told you, and stoneware. As today I'm here, now there are a lot of distractions here. I am home, so somebody's asking something from this side, somebody is telling me something from that side. I have to, so this is the main problem when you are at home. So now ceramics were started using in time of Neolithic time, that is the Stone Age. That is the, you can call it patthar ke waqt, patthar ke zamane mein, right? So in the 20th, it was started in the 20th century. Their uses reached to, from making bowls to the semiconductors. They hold such properties, starting from the bowls. You can use them in making bowls and in the usage of other semiconductor properties, right? Some kind of advanced ceramics include alumina ceramics, which are, you can say, used in missiles, right? And in the rocket nose cones. And other advanced usages include uranium oxide, that is UO2, ceramics used in the nuclear power plants, right? And elements like laser materials, ceramic capacitors, and different type of piezoelectric materials. So in 1950, the most important types of ceramics were the traditional ones, right? That were clays, right? Clays, and that were made from the, made into pottery. Pottery was the most important thing that is made from ceramics, right? That is the mitti ke bartan, you call it, and mitti ke bartan, made up of clay, right? So bricks, and they are made up of bricks and tiles. These are all the things that are, you can say. So ceramic artifacts play an important role in historical understanding of the technology and culture of the people, of course, who lived many years ago. It simply, comprises us, and it tells us the culture that was, there, and the people who were using initially ceramics. Things were all made up of ceramics. Mostly the things were made up of ceramics, right? So a ceramic material is inorganic material, right? It's non-metallic material, and it is also, you can say, often it is crystalline, right? So I was telling you about ceramic. Ceramic is basically an inorganic non-metallic material and is often crystalline, as I just mentioned. Traditional ceramics are basically clays. They were basically clays. The earliest application was in pottery, right? A lot of pottery you have seen that is made up of ceramics. Now, most recently, different type of ceramics used are, for example, there are many examples like alumina, as I just told you, silicon carbide, etc. And the latest advancements are in the bioceramics, with examples like being dental implants and synthetic bones, right? This is also one of the very advanced applications that the ceramics are now used for. Pottery is one of the oldest human technologies. Now, what are the fragments of clay pottery found recently in Hunan province in China have been carbon dated to 17,500 to 18,300 years old. It was such a long time. Whereas nowadays the ceramics, the term ceramic you can say has more expansive meaning, and it includes materials like glass, right, advanced ceramics, and some current systems as well, ceramic systems as well. So now let's start the definition of ceramic. Ceramic is equals to inorganic non-metallic material. As I just mentioned before, it's inorganic non-metallic material. The word ceramic, it is derived from a Greek term called keramos, Keramos, which means pottery's clay, right? Pottery's clay. And keramikos means clay products or burnt stuff. That is, it is basically a burnt stuff. It comes from that word. This is the basic term that was used for it. That is burnt stuff, right? So a ceramic is an inorganic, as I just told you, non-metallic material, generally based on oxide, nitride, boride, and carbide. These are the basic chemicals that are used to form a ceramic, and they are made up of either metal or non-metal metallic compounds with the interatomic bonding in them. There is an interatomic bonding in between them, having ionic or covalent character. Even both, sometimes it's ionic, sometimes it's a covalent character. That is, both were being found, and they have been shaped and hardened by heating to high temperature. You can shape them, you can easily mold them by heating them at a very high temperature, right? As we were doing it, this is something too you can see comparable to the glass manufacturing also. From that also we used to heat it in the furnace. Furnace was there. So here also in some manufacturing process, the ceramics are heated in the in the furnace. Furnace is also used. So now if we comes to the next section, that is composition of ceramics, how ceramic is made. I just mentioned before, it is a non-metallic inorganic material, right, that it is comprised of, and compounds primarily compounds of oxygen, carbon, nitrogen, boron, and silicon. These are the compounds that are on, this is the combo of compounds that are used to make these. Now ceramic, as I just mentioned, it's made up of clay and chalk, silica, feldspar, right, and organometallic compounds. Now, what are organometallic compounds? You should know that what are organometallic compounds. And silicon carbide, alumina, and barium nitride. These are all the combo of compounds that are used to form this ceramic, right? Some ceramics are composed of only two elements, right? What are those two elements? For example, alumina is aluminum oxide, Al2O3. Zirconia is zirconium oxide, that is ZrO2, and quartz, silicon and of course silicon dioxide, that is SiO2. Other ceramic materials including minerals have complex and even variable compositions. For example, the ceramic mineral feldspar, right? Feldspar, one of the components of granite, right? And it has the formula KAlSi3O8, right? It was something like that. So now advanced ceramics are not generally clay based. The advanced ones, they are not generally made up of clay. They are not clay based. They are instead either based on oxides, right, or non-oxides, or you can say the combination of the two, oxides or non-oxide, or both, the combo of two. Typical oxides are of course alumina, that is Al2O3, and zirconia, ZrO2, and non-oxides are often carbides, you can say, or borides, and the nitrides, silicates. So I was telling you that the advanced ceramics are not basically clay based. Instead, they are, you can simply say they are based on oxides or non-oxides or combinations of the two. This was I just explained, right? Examples also I told you. For example, if the oxides are used are as you can say alumina, that is Al2O2, zirconia, and the non-oxides are often carbides, borides, and silicates, silicates, and examples all are boron, carbide, silica carbide, and molybdenum, and many others. So this all includes in the composition of ceramic, right? This is the ceramic composition. Now we'll come to the next topic. So now let's jump to the next topic, that is properties of ceramics. Now first I would like to tell you the chemical properties. So many ceramics contain a mixture of ionic and as I just mentioned, ionic and covalent bond between atoms, whereas industrial ceramics are made up of compounds of oxygen, heavy metals, carbon. For what type of metals? Of course carbon, boron, nitrogen, and silicon. So ceramics are chemically inert, right? That is, they do not react with most liquids like and gases and alkalis and acids, right? So they are basically chemically inert. Now if we'll discuss the physical properties, they are smooth, lighter in weight, low densities. They have very low densities. They are very hard, and they are and resistance to abrasions, right? Whereas they have very high melting points. They are opaque and porous. They can resist to a high thermal shock. They are resistant to high thermal shock, whereas corrosion resistance and heat resistant also. This comes under the physical properties of ceramics. So if we discuss the electrical properties, there are many things that are electrical, comes under the category of electrical properties. They are used in insulators, and there are certain ceramics such as porcelain, that is in Urdu you call it chini mitti ke bartan, we used to call it chini mitti ke bartan, so act as insulators, right? Now what are insulators? Again, a physical term. You should know what are insulators. Whenever I find a new term, I always focus on that term, that you should be knowing what are insulators. So tell me in the class what are insulators, or tell me in the comment section what are insulators. I would appreciate if you will ask and if you will answer my questions in the comment sections, and that would be appreciated, much appreciated by your teacher. So you are supposed to know these basic terms of science, right? So I was telling you about we were discussing the electrical, properties of ceramics, right? So I was telling you they can be, they are also used as common electrical and thermal insulators in the manufacture of spark plugs, telephone poles, right? The spark plugs, that is, you use them, right? And the electrical poles, electronic devices, many electrical devices, and nose cones of spacecraft. This I also want, that is nose cones of all spacecraft. These all are mostly made up of ceramics, right? So now let's discuss the applications of ceramics or uses, which is very interesting, and which is, everyone almost know them, but let's discuss them as a very important step in discussing ceramics, right? So for centuries, ceramics are used by those who had little knowledge of their structure. Today, understanding of the structure and properties of ceramics is making it possible to design and engineer new kind of ceramics, right? So ceramics are used in many areas, such as you can say constructive materials, for example, as bricks, roof tiles, sinks, and toilet bowls, right? Toilet bowls, and decorative items also include ceramics, for example, pottery, plates, glasses, vases, and different types of tiles. Tiles are also made up of ceramic. Tiles are also very much common nowadays. So these are some beautiful, daily use applications which ceramics are used for. So these are all very interesting and very easy to memorize also. They can be used as electrical insulators, as I just mentioned. So and for insulator for toasters, refrigerators, and electrical plugs, for example, in the field of So now, as I was telling you about the applications and usages, so they were, used for the medical. In the field of medical, we cannot avoid the field of medicine and medical world. The world of medical, it uses a lot of types of ceramics, right? So, for example, in the denture, that is for dental treatments, and for dental part, it is used mostly used. That is masnui, you can say artificial dentures, and prosthetic limbs also it is used, right? So these are the few things which I have just read about. In the field of medical field, where they are usually making for, you can say, strong, hard, and abrasion resistant materials, right? So in textile industry, ceramics resist the cutting action of fibers traveling through these guides at very high speed. Whereas scientists discovered a family of superconductive copper oxide based ceramics. That is, what are those? There are a few examples of them. I will explain you later. Now, if we discuss the types of ceramics, there are basically four main types which are very, interesting. That is whitewares. These are cookware, that is pottery and wall tiles, right? And number two is structural ceramics. These are bricks, pipes, roofing tiles and floor tiles. Whereas third is technical ceramics. These are also known as special fine, advanced, or engineered ceramics, right? And these class also includes bearing, you can say, some sort of special tiles, like for example in spacecraft and heat shielding. Whereas in the biomedical implants, ceramic brakes, nuclear fuel, ceramic engines, and ceramic coatings, right? So these are all the types, important types which you are supposed to memorize. And there is a fourth type also, that is refractories, right? They are used to make crucibles and lime kilns and that can radiate heat in gas in fireplaces. So this is also one of the very important type of the ceramics. So I hope you find all this information regarding ceramics today very interesting after studying the glass in detail. Now ceramics are also there in our world, in the world of Dr. Moina and their students and their followers and their all the people who are watching all this about ceramics. Though it's not a very interesting topic for people, but for those who are directly concerned learning about ceramics, it's important. With a beautiful background and a beautiful fish floating, you can see the fish, beautiful fish. They are showing you their beauty also in the background. So that is also an additive part of learning ceramics today. So now let's jump to the classification of ceramics. What is the classification of ceramics now? There are basically four important categories that the classification is based on. That is traditional and advanced ceramics. Then number two, amorphous and crystalline ceramic, and you can say ceramics by elements. You can classify them via elements. You can classify them by materials simply. So if we discuss the traditional and advanced ceramics, these are older and more generally known as types. For example, when the types include porcelain, bricks, earthenware, etc. Whereas the advanced ceramics includes, they have been developed over the past half century. Now based primarily on natural crude raw materials of clay and as silicates. And these include industrial inorganic chemicals like artificial raw material that exhibit specialized you can say specialized properties and that require more sophisticated processing. So whereas the applications includes building materials like brick, clay, pipe glass, household goods like pottery, as I just mentioned before, cooking ware, glassware, and different type of manufacturing like abrasives, electrical devices, insulations, fibers. And these are all the applications that are supposed to be done when you are doing this. You are classifying ceramics. Whereas in the advanced ceramics, the applications are simply artificial bones, cutting tools, engine applicators, silicon. For example, the compounds that I use are silicon nitride. So I was discussing with you, I mean, the different, you can say, the classification of ceramics, and I've explained two basic types of classification. Now if you will jump to the second or third type, that is amorphous and crystalline ceramics. So amorphous ceramics, now what is amorphous? Of course, atoms exhibit only short range order, whereas no distinct melting temperature for these materials are there. That is with the crystalline materials, for example Na2O, calcium oxide, K2O, etc. Whereas the crystalline ceramics, if we discuss about the crystalline ceramics, these are atoms or ions that are arranged in a regularly repeating pattern. You know the crystal structure. I discussed crystal structures many times, the crystal lattice, remember? So it is simply the same thing, that the atoms or ions are arranged in a regularly repeating pattern in 3 dimensions, that is, they have long range order, right? Crystalline ceramics are the engineering ceramics, and they have high melting points, and they are strong, hard, brittle, and they have good corrosion resistance. Now the examples are silicon nitride, that is Si3N4, silicon carbide, SiC, zirconia, that is ZrO2, alumina, that is Al2O3. So this is the second type. I just classified you. The third includes ceramics, that is if you classify them with the help of elements. Now what are those elements? Aluminates, arsenides, borides, carbides, ferrites, niobites, nitrides, phosphides, silicides, titanates, and zirconates. So these are all the long range of elements. And number 4 is we classify them by material composition. If you just classify them with the materials, that is, they are composed of, they are based on the raw materials, and this is also divided into silicate and advanced ceramics. Now what are silicate ceramics? Of course, compounds containing the anionic complex called silicon, SiO4. For example, the silicate group is there. For example, what are those examples? That is porcelain. Porcelain is number 1 example. Number 2, magnesium silicates, that is MgO, SiO4 and SiO2, and mullate or porcelainate, that is 3Al2O3 and 2 SiO2. So these are the formulas. I have to discuss everything with you people with the distractions, because I'm home, so distractions are always there when you are home. So I hope you will not mind all those distractions, and you will not be distracted. It's you who's not supposed to be distracted. You are supposed to concentrate on the subject I'm teaching you right now. Whereas if we discuss the advanced ceramics, these are oxides, non-oxide ceramics, and composites, right? Now what are oxide ceramics? Of course, alumina. Alumina is the best example for that, and alumina, zirconia is the second example. Alumina is the first example, zirconia is the second, and these have oxidation resistant, electrically insulating, chemically inert behavior. What are the examples? Of course, aluminum oxide, titanium oxide, magnesium oxide, all these oxides. So these oxide ranges there, and zirconium oxide, lead oxide, right? They have their all the formulas. I hope you know Al2O3, then titanium oxide TiO2, magnesium oxide MgO, and zirconium oxide ZrO2. These are all the 4 basic oxide ceramics, right? And non-oxide ceramics includes carbides, borides, nitrides, right? These are all include in the non-oxide ceramic forms. These have low oxidations. Now keep this thing in your mind. These have low oxidation, and they are resistant, and extremely they possess hardness, and they are chemically inert, right? Now what is chemically inert? Another chemical term which you are supposed to learn. What do you mean by chemically inert? What is chemically inert? I will ask you, and I want answers in the comment section. What do you mean by chemically inert, right? Now carbides and nitrides are the most important compounds of this group. Now examples are Carbide Ceramics, right? Boron carbide, silicon carbide, tungsten carbide, and which we call it WC, right? And nitride ceramics, and boride ceramics, aluminum boride, for example. So we were discussing the advanced ceramics, right? And I explained you the oxide ceramics and of course the non-oxide ceramics. Now let's discuss the composites. Now what are composites? Composites, these are simply particulate reinforced combination of oxides and non-oxides. Examples are silicon, aluminum, oxynitride, right? And silicon carbide and ceramic foam filter, that is CFS. Now it holds toughness, right? Low and high oxidation resistance type, and variable thermal and electrical conductivity is there. And these are all complex manufacturing processes, and they all hold very high cost, right? They are costly. So these were the three different categories, that is oxide ceramics, non-oxide ceramics and composites. So I explained you all these three different types. You should memorize all these things, and you should remember all these things. I hope you will find today's lecture interesting, and you will go through your scheme which has been provided to you, and you will go through the book that has been recommended to you for learning ceramics. And today we have gone through the classifications and the types and the introduction of ceramics and many other interesting things we have discussed. I hope you find this lecture interesting, though I know nowadays everyone is again a bit so fearful. Again, we are having fears that again COVID is coming back, COVID is again increasing, and a lot of our loved ones have lost their lives in this this disease is simply very scary. And so I know that you are now packing up your material, and you have been told to leave university, and you will soon be packing up, and you will be going back to your home. So we'll be connected online again, and you should be connected to your teacher, that is Dr. Moina. Mughal is always available online, so please go through my videos, go through the updates, and subscribe this channel so that you can have the all the things updated. You will find there, and you will I'm now going to upload, of course, the assignments that will carry marks, right, for your examination. That will be that is part of your examination process. So please stay in touch with Dr. Moina on YouTube, right? I hope you find today's lecture interesting. You will share it with your friends. You will share among each other. You will ask, just go through the lecture one by one, go through all the steps one by one, and then just try to memorize things that are supposed to be learned easily, and you can easily absorb them, and go through the books that are referred to you for to memorize things more clearly, and go through the pictures of the ceramics, the types which I just mentioned. I've mentioned each and every type there. I mentioned with the formulas. Go through the formulas that are made in the composition for making up, for manufacturing ceramics. These are all beautiful things, and this is a very simple and interesting chapter to cover. So I thought that I must share all these things with you people, because you are directly connected to me, and I know you are watching me, and you will watch the videos because you are now going to get lot of benefits by watching this video, right? Those who are learning it as their coursework, it's good for them. Those who are just learning it for their own knowledge and for their own interest, it's good for them also, because whenever you read in olden times, nowadays also book readers are always there, but you can say that when nowadays everyone opens the YouTube, opens Google, there are different sites, and they get the knowledge they are looking for. So this is right now the best time to gain knowledge, and to gain the things that are used for I've just explained to you people, and that would be helpful to you. Thank you very much, and see you in my next topic of ceramics. Stay connected, because soon I will upload the next topic. Okay, so stay connected with Dr. Moina Moghal.